So in this video we're going to rationalise these four expressions, and they all contain surds. So this is a continuation of videos all about surds. So check on the link below and you'll see some other examples of different ways of dealing with surds. Okay, so how are we going to rationalise this one first? So let's call that one A. 2 divided by 2 plus square root of 3. Now what we want to do is to try and get this surd out of our denominator. So what we have to do is create a 1. So what we'll do is we'll use this term in the bottom, but what we will do is we'll just flip the sign. So instead of 2 plus root 3, we'll multiply it by 2 minus root 3, and then you'll see why that is. I'll just write that up, and then 2 minus root 3. So as the numerator and denominator are the same, this is essentially a 1. So all of that is 1. So now what we need to do is we need to do multiplication as per fraction. So this fraction multiplied by this fraction. Okay, so 2 times all of this. So we've got 2 times 2 minus root 3. That's our numerator. And then here on our denominator, we've got 2 plus root 3 times 2 minus root 3. Okay, so let's move on to the next stage. So we now need to distribute the 2 with both terms. So 2 times 2 is 4. And then 2 times minus root 3, not forgetting the minus sign, that's minus 2 root 3. So that's what we got for our numerator. Now here in our denominator, we've got something really interesting here. Because we flip the sign, we've got a result here when we multiply these together, which will give us a difference of 2 squares. So we can, instead of falling out the 2 with that one, and then the root 3 with those ones, we can just go into a shortcut. All we need to do now is, instead of all of this, we can just square the first term in our brackets. So 2 times 2, so we just write that as 2 squared to show us the difference of 2 squared. And then plus and minus, multiply those together, we'll always end up with a minus. And then we've got root 3 and root 3. So then we've got root 3 squared. The reason we don't need any other terms is, if I just distribute these ones and these ones, which I obviously haven't got on here, I'll have 2 times minus root 3, so minus 2 root 3. And here I'll have plus 2 root 3. Hence these will be 0. That's why we don't need them on there. So the difference of 2 squares is a nice shortcut for our result. Okay. So now all we need to do now is just simplify our denominator. So now we've got 4 minus 2 root 3. And then here we've got 2 squared, which is 4. So that's 4. And then root 3 squared is just 3. So that's 4 minus 3. So that then just becomes 4 minus 2 over root 3 over 1, which is obviously just 4 minus 2 root 3. And that will be our answer to our first one. Now the second one, let's have a look at this. This time we've got a minus sign. So let's see what happens here when we produce our 1. So as we did here, we produce a term that's going to be 1. So using our denominator, we've got 3 minus root 2. So what we want to do is flip that sign. So now we have 3 plus root 2. And hence we need the same on our numerator. Okay, so now as we did before, let's just multiply all of these along. So now we've got 7 times 3 plus root 2. And then here, we just go straight into the difference of 2 squares. So we've got 3 and 3, which is 3 squared. So 3 times 3. And then minus root 2 times plus root 2. So we'll have a minus. And then we've got root 2 squared. Okay, let's just simplify this off a little bit more. 7 3's 21. And then 7 times positive root 2. So that's plus 7 root 2. Okay, onto the denominator. We've got our difference of squares. So we've got 3 squared, which is 9. And then we subtract that from root 2 squared, which is just 2. So in the bottom here, in this denominator, we've got 9 minus 2, which is 7. So that's our denominator. Now here we've got an interesting thing. We've got 21, 7 and 7. Now the denominator will go into each of the integers on the numerator. So we can divide by 7 with all of these terms. So 7 into 21 goes 3, and 7 into 7 goes 1. Remember, we have to distribute with both of these terms opposite the plus sign. So then we're left with 3 plus root 2. And there's no denominator, so then that is our answer. We cancelled out the 7 with each of these terms. So that gives us our result. Now, what about this one? This time we've got a surd in our numerator. Now, to start with, we still produce a 1. So business as usual there. So using our denominator in the question, let's call this one question B. So on to question C, 5 minus root 3. We can just flip the sign on that one. So write that as 5 plus root 3. Hence we get a difference of 2 squares when we multiply. So I'm just going to write that in brackets so we can see that clearly. And then square root of 5, that will then go with 5 plus root 3 in our numerator. So that then creates our 1. Now what we do is, we have to distribute now square root of 5 with all of these terms. So we've got root 5 times 5 plus root 3. So we've got to be a little bit more careful here on this one. And then our denominator, again, using our difference of 2 squares, 5 times 5, well that's just going to put that as 5 squared for now. Plus and minus, it's going to be a minus always. And square root of 3 twice, so square that. Okay. Now this time, let's pay particular attention to our numerator. We have to distribute the square root of 5 with all of the terms inside here. So square root of 5 times 5, that's 5 root 5. And then square root of 5 distributed with the plus 3. 5 3s are 15, so then that's just going to be square root of 15. Square root of 15. Now, can we simplify that any more to make it into a surd with an integer? Well, no square numbers will go into 15, so that will stay as it is. Now, our denominator, 5 squared is 25. Square root of 3 squared is 3. So 25 minus 3, that gives us 22. So then that will be good for our answer. Okay. Right. Now what about this one? This one's a bit interesting. We've got something different going on here. So question D, integer in the numerator, no problem. But here we've got the surd first, and it's 7 root 3 minus 6. So what I want to do here is to change this round to put the surd in second place on our denominator. For this expression, 4 will stay on my denominator. This time I'm going to flip it round and put the minus 6 first. So I've got my integer first, and I've got 7 root 3, which would have a plus sign here if we wanted to put one. So now I'm going to write plus 7 root 3. Okay, now we've got a minus sign in my denominator. If I wish to, because I haven't got one in the numerator, I can just put that up to the top. So that can then come from there, and I can put it here. So that's a bit more recognisable. Okay, so now I need to produce my 1 like I did here. So back to normal business when we try and rationalise our denominators. So 6 plus 7 root 3, we're going to use that to create our 1. So now I'm going to write that as 6 minus 7 root 3. So same terms, flip the sign. And then I need to put the same again in my numerator. Okay, now what I do is, sorry, this should be a multiply sign, not an equal sign. So now what I need to do is multiply all of these terms across. So minus 4 times 6, that will give me minus 24. And then minus 4 times minus 7 root 3, don't forget this minus sign, Minus and a minus, that's going to give us a positive. So I'm going to write positive, and then that's going to give us 28 and root 3. 7 fours are 28, and then the root 3 will stay. Okay, what about my denominator? Well, again here I'm going to have a difference of 2 squares, but just being a bit careful with this one. So 6 times 6, so if I just bracket them, just to be careful on this one. 6, that's 36. And plus and minus gives me the minus as always. And now I want 7 root 3 squared. So let's take this one step at a time. So to square this, we're writing this equivalently as, if I just put this up here, 7 root 3 times 7 root 3. First of all, to evaluate this, I multiply the integers together. So that equals 7 7s are 49. And then root 3, so now multiply the surds together, that's just going to give me 3. So that's then just multiplied by 3. So that will give me 49 times 3, which is 147. Okay, so my denominator now is 36 minus 147. Okay, so just checking that, 36 minus 147, that's going to give me minus 111. That's what that becomes. So that's my denominator. Now I see I've got minus and a minus on the numerator and the denominator. So what I can do is now I can just cancel those out and turn them into positives. So that's nice and easy for me. Now I've got 24 plus 28 root 3 over 111 as my final answer. So let's just take this working off so I can fit in my answer. So that equals 24 plus 28 root 3 over 111. And that's going to be my answer to question D. Okay.